Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 9 minus 512 is equals to 0, and we will solve for all 9 roots of this equation. So that the very first thing we are going to do is, here first I can rewrite this equation as n to the power of 3 and its whole power 3, and here you have 512, and you know that 2 to the power of 9 is equals to 512, and we can write this as 2 to the power of 3 and its whole power 3 is equals to 512. So now we can just replace this 512 by 2 to the power of 3 and its whole cube. So it will becomes 2 to the power of 3 and its whole cubed is equals to 1. After this step we can use here the nice cubic formula, and you know that if we have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b squared. So now we can apply here this nice cubic identity, and you get the output in the form of n cubed minus 2 cubed, because here we have the value of a is n cubed, the value of b is 2 cubed. So here we have a minus b, which is n cubed minus 2 cubed times of n squared or a squared, and the value of a is n cubed and its whole squared, and plus ab, the value of a is 2 cubed, or value b is 2 cubed and a is n cubed, and plus b squared, the value of b is 2 cubed and its whole squared is equals to 0. Now we will open this equation again using this cubic formula, so that here you have n cubed minus 2, it is equals to n minus 2 times of n squared plus 2n plus 2 squared into, here you can simplify the terms and you get n to the power of 6 plus 8 times of n cubed plus 2 to the power of 6, and whole is equals to 0. So here we have three cases. The first case is you take n minus 2 is equals to 0, and the second case is you take n squared plus 2n plus 4 is equals to 0, and the third case is you take n to the power of 6 plus 8 n cubed, plus here you have 2 to the power of 6, and 2 to the power of 6 will be equals to 64, and whole is equals to 0. So I can name these three cases as, this is the case number 1, this is the case number 2, this is the case number 3. So now first I can solve case number 1. So our first case is we have n minus 2 is equals to 0, and easily you can get n is equals to 2. So this is the first value of n which we can get from case 1, and now we can solve case number 2. So our case number 2 is n squared plus 2n plus 4 is equals to 0. I can write again here n squared plus 2n plus 4 is equals to 0. And now we can apply here the nice quadratic formula, so that here you have the value of a is 1, b is 2 and c is 4, and our nice quadratic formula is n is equals to minus b plus minus b squared minus 4 times of ac square root over 2 times of a. And now we can put all the values of a, b and c in this nice formula, and you get n is equals to minus b, the value of b is 2, so it will becomes minus 2 plus minus b squared, and b is 2 squared is 4 minus 4 times of a is 1 and c is 4 and its whole square root over 2 times of a, and a is 1, so it will becomes only 2. And now you can simplify these terms. So the simplification of these terms is equals to minus 2 plus minus, here you have 4 minus 4 for the 16, and 4 minus 16 will be equals to minus 12 and its whole square root over 2. So it will becomes minus 2 plus minus, here I can just separate the square root, which is negative term, and 12, and we can write 12 as 4 times of 3 square root and square root of minus 1 over 2. So here you get minus 2 plus minus square root of 4 is 2 times of square root of 3, and minus 1 square root is equals to iota over 2. And now we can just separate these terms, and you get minus 1 plus minus square root of 3 iota. So these are the other two values or two roots of the given equation. So here we can get three roots, and now we can move towards the case number 3. So this is the our case number 3, and we can write this equation as n cubed and its whole squared plus 8 times of n cubed plus 64 is equals to 0. And now we can simplify these terms, and here I can take y is equals to n cubed. So when you can put here y is equals to n cubed, then you will get this case in the form of y squared plus 8y plus 64 is equals to 0. And now you can again apply here the nice quadratic formula, and you know that here we have the value of a is 1, b is 8, and c is 64, and the quadratic formula is y is equals to minus b plus minus b squared minus 4 times of ac square root over 2 times of a. And now we can put all the values of a, b and c in this nice formula, and you get y is equals to minus b, and the b is minus 8 plus minus b squared, 8 square is 64 minus 4 times of a is 1 and c is 64 and its whole square root over 2. So that now we can just make some simplification here, and you get minus 8 plus minus, here you get common 64, and you get 1 minus 4 square root over 2. And here you see that the square root of 64 will be equals to 8, and here you get 1 minus 4 is minus square root of 3 over 2. And now we can just make the separation of these two terms, and you get minus 4 plus minus 4 times of square root 3 into iota, because here you can just make the separation of minus. And now we will back substitute the value of y, and here you see that we put y is equal to n cubed. So when you can put here n cubed is equals to y, then you get n cubed is equals to minus 4 plus minus 4 times of square root of 3 iota. And now we can take the cube roots on both of the sides, and you get n is equals to plus minus of minus 4 plus minus 4 times of square root of 3 iota and its whole power 1 over 3. So this root will become the sixth root. When you can open plus minus and this plus minus, you will get the 6 roots from here, and in the above statement we will find 2 roots of this one, and one root is n is equals to 2. So after combining you will get the total 9 roots are, so here you get 6 roots from here, these are 2 roots, this is 1 root, and this will becomes total 9 roots, and this is the our final answer. Thank you so much for watching this video. Please subscribe to my channel for more exciting videos.